Okay, let's start with the basic of probability. Probability is a set, um, is a well-defined collection of objects which are the element of the set. And if we think of S as a set and X is an element of S, then we can write a set X is an element of S like this, you can see. And if we think about a real life example here, is a set of fruits. If we think of the fruits, banana is a set of fruit. uh, you can think of more examples like this. You can pause the video, think about some more examples and write it down in the comment section by mentioning the timestamp. And the next one is, if X is not an element of S, then we can write simply it as X is an X is not an element of S. And if we think about the example of the set of vegetables, then we can say that banana is not an element of vegetable part. These are two real life example parts. You can think about more examples like another example that suppose if you think of the set of all the boys in the all the boys in your school, and if we name a girl here and make it a make the name here, suppose uh, Ananya is not an element of set of boys. If we think of a set of boys here, okay, set of all the boys, the names are written here. Okay, and these are not that much hard thing to remember or to think of. Then we are proceeding towards our next part, that is if S contain infinitely many elements, we can write it as s x1 x2 x3 xn dot 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 xn up to xn. And we can write it as s in an element of x1 x2 x3 up to xn. We will think of a real life example, set of all the elements present in a circle, all the tangents, sorry. If you think of the tangents, there are many tangents in a circle. You can't able to draw even all the tangents. If you didn't able to understand that one, I am simply showing it. Check here. Sorry, it was creating disturbance, so we adjust the light here. If you think of a circle, it has many tangents, infinitely many tangents. We take T as set of all tangents of the circle, all tangents of the circle. So T is an element T1, T2, T3, T4 up to T can goes up to infinity. Okay, let's move to the next. Complement of a set with respect to the universal set omega. Before understanding this one, please understand the real life example first, then we will able to understand the written part. So the real life example states that set of all stars in the universe, okay, sorry, set of all stars in the universe are is a set. And suppose we think of that is like omega is the set of all the stars which are planet, and omega is the set of all the stars that are planet, and X is the sun, and X days are other planet which are not stars. So X is an element of omega, means sun is an element of stars. X is not an element of S, means other planets are not an element of S. The simple meaning of this line is that sun is an element of the stars which are planet, and other planets are not an element of stars. S is the complement of omega here. Okay. Next is union of two sets S and T. S union T means all the elements of S combining with all the elements of T. We will combine and write it in a set. Okay. Suppose we think of an example, real life example. X is an element where X is the people of India. Okay. And X is of reserved and unreserved. This is the union of the set, union of that set. The first set here is reserved category, that is provided as S here, and the unreserved category is written as T here. Then if we move further, that is an intersection of two sets. S intersection T means it is common in the two. X is an element of S and also an element of T. In waving, the intersection of horizontal and the vertical threads, it is an example of the intersection of two sets. If we make a set of the horizontal threads and another set of vertical threads, the point where the threads crosses each other is the set of intersection of that two sets. Okay, these are not much heavy thing you have already read in class 11. You can watch it in 2x speed, it is recommended. Okay, let's move to the next one. When n equal to 1, it goes up to infinity, so the union of Sn equal to S1 union S2, it is taking the all the elements of that element, and the intersection, if we think of if we start from S1, it will move up to S infinity, considering all the common elements of S1 to infinity. Okay, let's move to the most important, De Morgan's law. It is the most important one. You read this, then you will able to understand this one, and you first read this and you will understand this one. If we take an union of two sets and complement it, then we can simply write as the complement of individual A set intersection complement of individual B set. Accordingly, we will think of a set A intersection B, then its complement is equal to complement of its individual A set union B complement set. This is wholly the De Morgan's law. Next is, if so this is not the next part. It is just simply saying what we call a intersection of B. This is the summary of the previous page. A intersection B. This is A not B, and this is A union B. This is A, not the intersection part of A intersection B. It is considering the A union B minus of A intersection B. This is just simplifying that one. Okay, this is the symmetric difference, and this is the difference A not B. Okay, is it simple now? So if you think of a set omega considering A, B, C, D, E, A is suppose think of vowels and B is consonants, so BC. So A union B is simply A union B complement will be the elements, all the elements A, E, B, C, it is taken by A union B. The rest element of A union B is D. This will be the complement of A union B. It is very simple. You already read it about it in the earlier. So if we think of, we are just simply proving one axiom of De Morgan law. So if we take the individual complement of A set, it will be B, C and D, if you see from here, and B complement will be simply A, D and E, as BC is on the B set. So A complement intersection B complement will be, you need to check the common between those two. So here D is common in between the two, so A union B whole complement means if we take A union B whole complement, that is also D element, and if we take individual A complement intersection B complement, it is also D. So hence proved one axiom of De Morgan's law. You can also prove the another, that is A intersection B whole complement equal to A complement union B complement. You need to think of an example, a real life example that will be placed here, and you need to check the timestamp of the video and need to post the answer in the comment with the timestamp. You need to think of all the examples I taught how to you to write down in the comments. Here will be the example of De Morgan's law. In the previous one, you need to think of some more examples of x is an element of S and x not an element of S, and the complement of sets example, and think of another example of infinite set. And you also need to think of about the union of set, some examples of that one, and intersection of sets. Then think of examples of this De Morgan's. We read this much in this video. So this is the basic part of the probability theory, no, basic part of set theory, but this basic will be needed to understand more about the concept of probability. So you need to learn all the concepts shown in this video in great detail. So complete it, and in the next video we will start from the basics of probability, and we will start from the probabilistic model. Okay, thank you for this video. We will again meet in our next video. This 30-second video is very important. Thank you.